Hello wonderful person, this is Anton, and in this video we're going to be talking about another terrestrial planet that might potentially have life on it. This time we're talking about a planet we don't usually talk about, Mercury. It seems that one of the recent studies made a suggestion that Mercury has transformed quite dramatically in the past few billion years, and may have at some point been even habitable in some parts of this planet. So when it comes to habitability, or essentially ability to preserve life and to create life and to have life evolve over time, and more specifically have liquid water on the surface, we've always talked about three major candidates. Obviously our planet Earth that had several cycles of habitability and changed its surface quite dramatically over the period of about 4 billion years. We obviously also talked about Mars many different times, and life possibly even still existing here somewhere beneath the surface. We've also talked about Venus, which once upon a time most likely looked like Earth and had a very large ocean, but also possibly still has life in the upper clouds. Although this is something we need to do kind of investigate, and hopefully some of the future missions will do just that. But we've never really talked about Mercury, which, despite sort of looking like our own moon, and despite still being a terrestrial planet, is a little bit too close to the sun and potentially just doesn't have much atmosphere or really any other conditions to support water. This is what we've believed for many years, but the recent study sort of argues against that. And it even presents an idea that maybe once upon a time there was liquid water, but that liquid water did not exist in the same way as it did on Venus and on Mars. This was water hidden underground. So what exactly are these scientists proposing? Well, first of all, when it comes to our own planet, Earth, we've actually discovered, at least in the last few years, life in some of the more unusual places here. I think about 2 years ago I've talked about how we actually found life underneath our soil. Specifically, if you were to dig deep into the ground here and try to actually look underneath the surface up to about 5 kilometers deep, you would discover a tremendously massive world of various bacteria and viruses living and thriving underneath our feet. Also, a lot more recently, only a few weeks ago from when I'm making this video, we discovered life inside the actual ocean crust underneath the ocean in the conditions where really nothing should exist. But we've also discovered bacteria living there as well. So essentially, finding life underground is pretty common here on our planet. And even though the temperature on the day side of Mercury can reach up to about 400 degrees Celsius or about 750 Fahrenheit, this doesn't mean that life could not exist here in some of the darker areas, or possibly in the polar regions where we have actually recently discovered quite a lot of water ice. And one of the recent videos even explains how all of this ice is produced. But that's not really what these scientists are talking about. They're talking about some of the historical events that seem to suggest that Mercury has dramatically changed with time and may have actually possessed a very large ocean underneath the crust, liquid water underneath the planet. This proposition is actually based on the fact that if we were to look at Mercury today, as we have in several different missions, and more specifically, the most recent mission was the Messenger mission that explored Mercury with a lot of different studies that it conducted around Mercury for several years, we would discover something a little bit unusual. First of all, it seems like the planet has actually shrunk over time, and second of all, there seem to be areas on Mercury that suggest some kind of a implosion, essentially as if the ground collapsed, as if something sucked it in or something made it collapse from within. And this is something we didn't really expect to find, and some of the scientists, in the past at least, explain this away as possibly the result of a major collision on Mercury, which almost certainly did happen. And the collision itself very likely did actually dislodge a large part of the Mercury's mantle, although this collision here was a little bit too small. Let's try this again. And at the same time, it created a lot of other deformations that are still observable. But when the recent study investigated some of these deformations, and when it actually tried to look at the potential age of these different surface features that we have on Mercury, this study right here discovered something completely different. It discovered that some of these formations actually appeared billions of years after the initial collision. Essentially, this impact here could not really explain some of the other features we're observing, which also appear to be implosions of some sorts. And there is probably only one good explanation here, and the scientists behind this paper make a good point in trying to explain what they think happened here. They believe that, just like a lot of other terrestrial planets in the solar system, at some point Mercury very likely experienced a lot of collisions, and a lot of different materials, including various types of ices, things like water, things like organic compounds, were delivered to the surface of Mercury, and thus created really large deposits of water, and probably a lot of ice as well, underneath the surface, and also all over the place on Mercury. The scientists behind this paper believe that most of this water and most of these ices were actually hidden beneath the surface itself and created these really large deposits, not so different from various lakes we've discovered on Mars, including underground lakes we found not so long ago, forming these underground reserves that were essentially ice at first. But because Mercury is so close to the Sun and because there's a lot of heat generated, with time all of this ice started melting. But it's also possible that some of this ice was melted for other reasons, we don't really know why. Eventually though, a lot of ice turned into liquid water, potentially creating habitable conditions underneath Mercury, with some of the water being warm enough to actually support life. But eventually, even this water started to become vapor and then disappear and escape through various cracks in the surface, essentially creating these really large, but at the same time also completely empty caverns, which eventually collapsed because there was nothing to support them. And all of these collapsed caverns created all of these unusual features that suggest implosions all over the surface of Mercury. In other words, it seems like there was quite a lot of various ices and essentially a lot of different water reserves underneath Mercurian surface. Now, obviously this doesn't suggest that there was life and that life was created at all, but assuming that the conditions were similar to early Earth and possibly early Mars, assuming that there was actual liquid water and organic compounds, and also, as I mentioned previously, considering the fact that we've discovered life on Earth in some of the most extreme conditions underneath the surface, this actually does not seem so implausible after all. Life could have totally existed there, it could have evolved there, and the thing is, it can still be around. Mostly because, even today, in the polar regions of Mercury, there's still quite a lot of various water deposits that we've discovered not so long ago. And some of this water is still being generated on Mercury even today, and I've talked about how this is done in one of the previous videos. In other words, it seems like the terrestrial planets in our solar system all have a reason and a chance to, at some point in their existence, create habitable conditions and to potentially help life evolve as well. But interestingly, the one planet we never really expected to have any habitable conditions now also has a reason to be the target for new studies. There's now a big chance here that we might find life underneath the surface as well, just like on Mars. And since in terms of mass and in terms of the actual size, both Mercury and Mars are not really that different, with Mercury actually having a little bit more magnetosphere as well, it's actually the only other terrestrial planet except for Earth that has magnetosphere, there's now a lot more reasons for us to go and investigate it in a little bit more detail. Maybe even this should take precedence over Mars, because Mercury most likely also has a lot more other materials on its surface. And okay, I didn't mean to destroy this planet, but basically, here's another one. When it comes to mining, Mercury probably has a lot more stuff for us to find, discover, and profit from. Mars, not so much. But since unfortunately there are no new missions planned in the next few years, we're not really going to find out more about Mercury until one of the countries decide to plan a mission there, possibly land there, explore underground, and maybe even decide to create a small colony for human settlers. And because we know that there's water there, there's no reason for us not to try. Because honestly, Mercury has now just become a little bit more interesting. Probably even a lot more interesting. I would even say that a lot more interesting than Mars. But I guess until someone decides to go and explore it, we're not really going to find out anything else. Hello wonderful person, this is Anton, and this right here is planet Mercury. Today we're going to be talking about this new research that came out very recently, suggesting that the ice that's hiding in various craters on Mercury may actually be formed, unusually, by the extreme heats from the sun. Which sounds really counterintuitive. So all of this mystery of course starts, well, technically almost a decade ago. This is the so-called Messenger mission that was launched by NASA I believe in 2004, and it was only finished approximately 5 years ago in 2015. This probe actually ended the mission by colliding with Mercury in order to measure certain properties of the surface. But during its mission, it also discovered something really unusual about this planet. While orbiting over the polar regions, it discovered that there were a lot of deposits of various types of water ice. Basically, the hottest or one of the hottest objects in the solar system, with the daytime temperatures right here reaching up to about 400 degrees Celsius or about 750 Fahrenheit, surprisingly had quite a lot of water ice, which can only be formed in really cold conditions. But not surprisingly, all of this ice was only hidden in really dark and really cold places, and there were actually regions on Mercury that never received any sunlight. Most of these regions are in the polar caps, so these regions right here that orbit in such a way that they never receive any sunlight at all. And every crater here, for the most part, contains quite a lot of water ice, quite hidden and quite well preserved. And for the most part, we actually thought that most of it was formed through the continuous action of various impactors, basically asteroids and comets, that very likely delivered water and a lot of other organic compounds to various objects in the solar system. This of course includes objects like Earth and objects like the Moon, Venus, and so on. And so here, the typical impact would generate just enough energy for all of this to create enough water molecules, which would then slowly fall back to the surface, and those molecules that basically get stuck inside the craters would probably be hidden from the sunlight and thus stay as ice forever. Or I guess until something happens to this planet. But the thing is, if you were to compare our own moon to Mercury, which surprisingly actually looks really similar, especially if you look at some of the more realistic of pictures of both the moon and the Mercury, it does actually create a bit of a problem here. For some reason, our own moon doesn't seem to contain as much ice in its polar regions as Mercury does. So we think that our own moon does have some ice, so very likely in similar regions, polar regions that never really experience any sunlight, but we haven't been able to find as much as there is on Mercury. And this mystery has not really been resolved until very recently. So the study that I'm going to be talking about today, that as always you can find in the description below, decided to investigate if there was any way for water to be formed, well, technically similar to how sometimes we form it here on Earth in various lab conditions. In a nutshell, under certain conditions, the surface of the moon and technically Mercury can actually start creating its own water naturally if enough heat is applied to the surface. But for these molecules to form, which you see right here, these are the so-called hydroxyl molecules, or hydroxyl radicals or hydroxyl ions as they're also known, with the basic formula of HO, something else needs to happen to the surface of the rock before they can start depositing these really thin layers on the surface. And this something comes from the sun. Essentially, the scientists behind the study believe that as the sun bombards the surface of Mercury, and essentially as the extreme heat is generated, a lot of reactions happen on the surface, starting with the fact that the highly charged solar winds, which usually contain quite a lot of different charged protons, as they strike the surface of Mercury, start generating these hydroxyl molecules, which then get deposited pretty much everywhere on the surface of Mercury where there is enough radiation from the sun. And all of this heat will then start stripping off these hydroxyl molecules, which create these really large tornado-like formations that start moving around Mercury, with some particles obviously escaping the planet, but some depositing in various regions on Mercury's surface, with many of these regions of course being craters. And some of these craters will never see sunlight for millions or possibly even billions of years. So essentially, the heat from the sun is thus responsible for generating a lot more ice water than would be there otherwise from all of the meteorite and comet strikes. And this obviously also explains why Mercury seems to have so much more of this water ice in its polar regions than our own satellite, the Moon, which doesn't seem to have as much or barely any, or at least nothing major we've discovered so far. So in other words, it's really these extreme conditions coming from being so close to the sun that seem to generate such large amounts of water that we've detected with the Messenger mission that we don't seem to find anywhere on the moon. And the scientists behind this paper also estimated that around 10% of all of the water ice on Mercury is probably produced in this way, whereas the other ice probably came from asteroids and meteorites. But discovering the fact that Sun seems to generate so many different water molecules with these really extreme conditions is actually very useful for us. Because now we can kind of use this science and this chemistry to try to find a way to generate water relatively easily by actually doing very similar things here on the moon. Now, we might not get as much heat and as much radiation, but there are ways for us to actually amplify the effects by, for example, installing various mirrors and then pointing them at a certain location on the moon. Or use something very similar to this to produce a lot of water for the upcoming Artemis mission that's going to be launched in the next decade or so. And since the surface of the moon already probably has a lot of these hydroxyl molecules on the surface as well, from basically being constantly bombarded by the sun, all we're missing now is a lot of heat. Specifically about 200 degrees Celsius, which would then release these hydroxyl molecules, allowing us to very easily create lots of water relatively quick. And although the current estimate for Mercury suggests that approximately 11 billion tons of water was created this way, it's quite possible that by using the similar technique on the moon, we might be able to achieve just as much. We might be able to produce quite a lot of water to supply various missions in the future. At the same time, discovering this unusual phenomenon on Mercury may also explain how so many various asteroids and various comets have also acquired so much various water molecules on their surface. Because by being bombarded with various protons and eventually converting them to hydroxyl molecules, which then sublimate and turn into water, this could obviously with time enrich all of the asteroids and comets with all of the water we're seeing on them. In other words, this unusual chemical reaction could have produced a lot of, if not most of the water in the solar system, although this of course needs to be verified in some of the future studies. Nevertheless, this is a really interesting discovery and will definitely serve us well once we decide to finally settle on the moon. But just the idea of generating ice with really extreme heats coming from the sun is actually kind of mind-blowing. Because, I mean, honestly, nobody ever thought that this would be a thing happening on Mercury and something that could even be happening here on the moon. Hello wonderful person, this is Anton, and today we're going to be talking about a new study that investigates the major differences and the reasons for these differences between Neptune and Uranus. They look so similar, but are they? Now, if you've been on the channel long enough, you know that my opinion of our solar system is that it is one weird and unusual place. Every major planet we have seems to be completely different from everything else we're observing out there in other star systems. We know, for example, that the terrestrial planets we have are very unusual, and planet Earth specifically is totally weird, although a better word is totally unique. And although there are a lot of things to say about other gas giants like Saturn and Jupiter, today we really are going to be focusing on this new study that tries to investigate the major differences between Neptune and Uranus, and more specifically identifies the reasons for these differences. So let's look at these two planets in a little bit more detail. Because I mean, if you just look at them from this angle, they do look somewhat similar. They're actually almost identical. It's very difficult to tell a difference between them. And so if I were to show you this, for example, and then instantly show you this, would you be able to tell which one was Neptune and which one was Uranus? They both have somewhat similar size and mass, they both have a relatively similar location in the solar system, they also both have rings. You can sort of see the very dim rings around this object, which is of course Uranus. But there are some really significant differences, and these differences needed to be addressed because this helps us understand how the solar system was created. So first major difference is in the way these two objects are spinning. Notice how Neptune spins almost aligned with the plane of the solar system, even though it's just a little bit more inclined. While Uranus, on the other hand, spins almost entirely on its side. The angle here is roughly around 98 degrees. In this beautiful simulation created by James O'Donoghue of NASA, who actually works for the Japanese Space Agency now, you can even see the main difference between the spins of these two planets. Which of course suggests that both of these planets must have experienced something to get such an unusual axial tilt. Over the years, we've also discovered that Uranus, despite being closer to the Sun, is actually a lot colder, and it seems to have a lot less storms on the surface compared to Neptune. Neptune does seem to produce a lot more various stormy activities. So there is more heat inside Neptune, it's farther away, yet at the same time seems to be warmer. There's something going on here. What could have possibly gave Neptune so much extra heat, especially heat on the inside, compared to its somewhat similar, I guess you can almost call it twin planet, Uranus, which doesn't seem to have any heat signatures and seems to be in equilibrium with its solar system environment. And to try to solve all of these questions and all of these problems, the scientists behind this paper right here that you can find in the description below decided to simulate a lot of different things that could have happened in the early solar system. And most of these simulations involved, obviously, collisions. So here obviously they took Uranus, for example, and then collided various things with it. Then they did the same thing with Neptune as well, making sure that all these collisions were under a different angle, different types of objects colliding, and of course with various speeds and different types of composition. And what they've discovered is that, well, there were several types of collisions that could have occurred to both of these planets that would explain pretty much all of our observations of their anomalies. So for example, as you just saw with Uranus right here, one of their suggestions is that there was probably a collision with a relatively large terrestrial planet, but it wasn't a head-on collision. It was more of a grazing collision in this manner, where the planet very likely just hit the side and possibly a lot of the parts of this planet even then started orbiting around Uranus, creating a kind of a ring that then ended up creating most of the moons that we're seeing today. In other words, it's very likely that this collision then resulted in the production of all of the moons we're observing around Uranus today. Which makes this exceptionally interesting because moons like this one, this is Umbriel, the largest moon of Uranus, could potentially be leftovers from this collision and could actually be parts of this ancient planet that collided with Uranus. That would be really interesting for us to investigate in order for us to study what these early ancient planets would have been like and if they were somewhat similar to various terrestrial planets we have today, such as Mars, Venus, Mercury, and Earth. On the other hand, this is not probably what happened around Neptune, because to explain the anomalously high heat coming from inside of this planet, it had to have received a terrestrial planet collision almost entirely head-on. And this planet very likely then actually reshuffled and rebalanced the inside of this planet, giving it an extra heat that it's now still kind of losing. In other words, this heat that initially was probably very high and very dramatic, as you can see, eventually dissipated, but it's still not completely lost, and this planet is still losing heat from the inside, thus creating all of these storms we're observing on the surface. And this type of a collision would also explain the very slight 28-degree deviation that Neptune has compared to the plane of the solar system. So in other words, this planetary collision gave it a little bit of an axial tilt, but not nearly as much as Uranus. And there are a few more pieces of evidence that support this idea, specifically if you were to look at the internal structure of both of these planets. Based on the gravity models, we've discovered that Uranus, for the most part, is more or less balanced. Its gravity is kind of pointing toward the center of the planet. But weirdly enough, Neptune is not, and it's a little bit shifted to the side. In other words, the planet's center of gravity is not entirely in its center, as if something kind of collided with it and got stuck there, thus giving it this extra density, providing extra gravity. And a few more things can be easily explained with these collisions, such as, for example, their unusual magnetic axes and the overall magnetosphere of both planets. That's kind of difficult to explain unless something major collided with these planets and really kind of shifted around all of the internal structures. But I guess the question now is, so where exactly did these two extraterrestrial planets come from? And the thing is, we don't even know if they were terrestrial, we just know that they were massive enough to cause these effects. Now we know today that there are quite a few planets we expect to have in the solar system that are missing. Like for example, this is one of the reasons we believe Planet 9 might exist, because we do think that at least one major planet was present in the solar system and it's no longer here. But at the same time, there are many other theories that suggest a lot more planets were present in the early solar system that are just no longer there. For example, today we know that Earth definitely received a collision from another planet. It's very likely Jupiter did as well, as did Mars. And for the most part, we have evidence of all of these collisions, and I've discussed this several times on the channel. So we know that at least 5 planets definitely existed, and they, I guess, collided with the rest of the planets. But this obviously doesn't answer where they came from. They could have been just leftovers from the initial planetary disk, or they could have been created through the collision of other planets that used to be here and eventually fell apart. So discovering the origin of these collisions and origin of these planets is kind of also important for us to understand how our solar system evolved. But thanks to these state-of-the-art 3D simulations from University of Zurich, we now have this pretty clear picture on how the Uranus and Neptune might have developed and why they're so different. Now, it's still just a hypothesis and it definitely needs a lot more support from the scientific community, but it is a pretty strong study and definitely gives us a pretty good idea of what happened to all of these planets in the early solar system. Hello wonderful person, this is Anton, and today we're going to be talking about Pluto, one of the most favorite objects for a lot of us, especially those of us who grew up when it was still a planet. Now, today I wanted to discuss one of the more recent discoveries that also suggests that there is actually a very large ocean underneath Pluto's surface, but most importantly talk about some of the more recent discoveries based on the observations from 2015. So what you're looking at right here is Pluto shining in all of its glory. This is a little bit exaggerated, but basically you can actually see the nitrogen atmosphere that Pluto does seem to possess. And this is something that was discovered by the amazing New Horizons mission back in 2015. And 2015 was essentially the biggest moment for Pluto and a lot of the researchers studying Pluto, mostly because New Horizons mission got to fly through this area and analyze a lot of the things in a lot of detail, while at the same time taking the most incredible pictures of the surface of Pluto as well. Now, normally, if you were just a regular person, this is kind of what you would see. If you were to fly by through Pluto, you would see this beautiful surface, and that's about it. But since New Horizons probe was also able to take photos of Pluto from the dark side, and also analyze Pluto using a lot of other devices, we now have a pretty good picture of what may have happened to Pluto back in the days. But more importantly, we might now have the explanation for how this beautiful formation was formed. The super famous image of the heart on Pluto, also known as Sputnik Planitia. And obviously at the same time while flying through this region we were also able to see a little bit more about Charon, the biggest moon of Pluto, which allowed us to understand a little bit more about this whole system as well. Now if you were to look at Pluto and its moons, you would see this beautiful dance of moons of Pluto, all 5 of them moving around in a very peculiar way. A way that's kind of difficult to explain because only one of them is tidally locked, Charon, in the middle, but the other 4 are kind of wobbling around. And at first it's a little bit difficult to explain all of this, but once we start thinking about what happened to Pluto and its surface, it starts making a little bit more sense. Now, one of the biggest unusual discoveries from 2015 that is still a little bit surprising today as well, is that the surface of Pluto is so different. And it also seems to possess a lot of, I guess you can call them signs of cataclysms. Signs of really violent events that most likely completely reshaped this object. And another unusual discovery was that the side we saw first was almost entirely different and I guess in some sense almost completely opposite of the opposite side that we actually got to observe a little bit as well. In other words, Pluto does seem to be in some sense very diverse and has a lot of unusual geological activity that would be really difficult to explain. Because it's a small object, it shouldn't really have any geological activity, yet it does seem to have something going on here. And what's most important here is of course this beautiful shape known as Sputnik Planitia, which also seems to have some kind of an unusual origin. Now, in the last few years, a lot of scientists started to speculate that Sputnik Planitia was very likely formed by a large collision. And some of the recent studies started to actually find more evidence for this and even identify something else on the opposite side of Pluto that actually gives us a lot more credibility. When looking at the opposite side of Pluto, scientists discovered these somewhat unusual rock-like formations, almost like ripples, located pretty much on the opposite side of the so-called heart of Pluto. And these unusual formations do actually help scientists to identify what may have happened here in the past, but what's more important, they may also help scientists to understand what's happening in Pluto, inside of Pluto, right now. Now here's what they think may have happened, and here's what they think is going on right now. And by the way, all of this was actually virtually presented at this event that was cancelled from being in person to being online. And so if you'd like to learn more about this, you can check it out in the link in the description below. And so seeing these unusual formations on the opposite side of the so-called Pluto's heart is of course an indication of a very large collision event, which essentially manifested in the formation of various structures on the opposite side of the impact, and the impact may have actually been really massive. In terms of the actual size, it was very likely size of the largest asteroid in the asteroid belt, Vesta. And here it was probably around 400 kilometers across and slammed into Pluto so hard that basically a lot of the materials ended up crashing on the opposite side, creating a lot of other craters we're observing. But the actual impact also generated several types of waves that then propagated throughout the entire dwarf planet. Some of these waves were moving really fast, and so they formed some of these other structures we're seeing. But as these waves propagated through the inside of the dwarf planet, specifically through the internal structure itself, it very likely was slowed down by something on the inside, because this is exactly what these scientists seem to be observing. Something slowed it down. And from Earth, we know that only one thing can possibly slow down these waves. That something has to be an underground ocean. So this also gives a lot more evidence to the presence of ocean underneath Pluto. Ocean with a depth of about 150 kilometers or about 93-94 miles, which is actually deeper than anything here on planet Earth. And remember, all of this was discovered during this brief moment in 2015 when the New Horizons probe decided to pass by right here, took some photos, got some data, and then flew to the next object, now known as Arakoth, which is of course this other object we've talked about in one of the previous videos. But going back to Pluto, this is a pretty interesting observation and also answers the question of why so many different features on Pluto are so different. At the same time, it also kind of explains why when looking at the surface of Pluto, we seem to be detecting a lot of really old asteroid collisions all across the surface, but almost nothing in the region right here in the heart of Pluto. And this is the center of collision where there's probably still a lot of various activity, a lot of different convection going on, and possibly a lot of other interaction between the liquid ocean and the surface that was created by this relatively large crater. And this is not a far-fetched theory at all, because something almost exactly the same very likely happened to Mercury early on as well. We know that when we look at the surface of Mercury, we seem to actually find almost exactly the same feature right here. This is known as Caloris Planitia. This is about 1500 kilometers or about 1000 miles in diameter. And on the opposite side, we also find unusual line-like formations that seem to indicate a large collision may have disrupted this planet, causing a lot of really interesting formations on the other side. And in case of these smaller objects like Mercury and Pluto, when the impact is large enough and when the planet or the dwarf planet is not massive enough, the impact causes the planet or the dwarf planet itself to act as a kind of a lens. And because it acts like a lens, it sort of magnifies the force on the opposite side, creating a lot of deformation as a result. And this is especially true for less massive objects or objects that are relatively low in density, like most dwarf planets. So when a collision occurs with these objects, there's actually at least two different types of waves that are being generated. The initial shock wave and then the stress wave that follows it. And because all of these waves move at different speeds and also the speed is also dependent on the material that it's moving through, it actually generates different formations on the opposite side, which can then be easily seen through different observations and measurements. For example, it will move really fast through the actual crust itself, but will move much slower through ice and really slow through water, which is how the scientists were able to deduce the formation of these features, which then explain that there's gotta be water on the inside. And more specifically for Pluto, it's actually the existence of various spherical features and also various surface fissures that can only be formed by these different waves that probably were a result of a large collision. And although these features can technically be explained without a collision, it's a lot more likely that a large collision did occur to create so many of them on the opposite side of this unusual formation known as Sputnik Planitia. And so even though this is a pretty good explanation for how this feature was created and how a lot of other features were created, we obviously still need a lot of follow-up studies and preferably even another mission to Pluto to try to confirm all of this. And this type of a collision would also explain why the Pluto is slightly tipped in its rotation. Also, it might explain the existence of other moons around Pluto, and the actual collision probably emitted a lot of various particles that then landed on Charon and gave it the peculiar deformed shape that it has today. So something cataclysmic probably occurred in this system a few billion years ago, and probably resulted in the creation of all of these moons along with a lot of other unusual features we've detected on Pluto so far. It could also be responsible for Pluto even having an atmosphere, or very thin atmosphere that is, as well as what seem to be relatively active geological conditions on the surface, some of which are kind of difficult to explain otherwise. Not to mention that this kind of a collision would be enough to actually even create this type of ocean underneath the surface, and may also give us a lot of evidence to suggest that this is how the ocean on Earth was created as well. But what's really interesting here is the difference between Pluto and everything we discovered on Pluto and the previously mentioned Arakoth. Here, the creation and also the conditions are almost entirely the opposite. The entire object was created in relatively peaceful, really slow conditions, where instead of an actual collision, the two parts here very slowly merged together, so slowly as a matter of fact that they kind of just blended in. There was no collision, there was no impact. Suggesting, of course, that some parts of the solar system never really experienced a lot of cataclysm or destruction, but instead stayed peaceful for billions of years. But anyway, Pluto is definitely a lot more interesting, mostly because of all of these unusual features, and mostly because a lot of us still believe that this is still a planet, or at least an honorary planet that it should be. But we'll talk more about this in some of the future videos. Hello wonderful person, this is Anton, and a few years ago NASA launched the wonderful InSight mission to Mars. This was a launch of a probe that's supposed to investigate a lot of various mysteries on Mars and hopefully discover what went wrong for Mars and why it changed so much compared to our own planet Earth. And despite some of the initial challenges, it was already able to send us a lot of scientific data that was analyzed, and now we know a lot more about Mars and actually have a lot more questions than we did before. Very recently, NASA released the so-called surprising year of science on Mars. This was essentially a combination of all of the data collected by the InSight mission, some of which was actually a lot more surprising than we thought. Now let's begin with some of the discoveries in regards to the so-called Marsquakes, basically earthquakes on Mars. We obviously expected Mars to be seismically active, in other words, possess a lot of earthquakes, but we didn't expect that many. Pretty much as soon as InSight probe landed on Mars, it started experiencing earthquakes and detecting them from all over the planet. And although none of them were really big earthquakes, most of them were about 3 to maybe 4, so basically this is kind of similar to what we have here on Earth on a daily basis as well. Nevertheless, they were able to detect about 450 earthquakes in total since the beginning of the mission. That's basically at least one or even more than one per day. Here's how the Martian earthquake compares to one on Earth, and although generally speaking earthquakes were present pretty much everywhere on the surface, some of the biggest ones were actually, let me try to find this, there we go, right here. This is the biggest volcano, or former volcano, in the solar system, the so-called Olympus Mons. Now here, this is a huge structure. Its height is basically 22 kilometers, and that's 3 times the size of the tallest mountain here on Earth. And because of the sheer mass of this object, it generates a lot of pressure on the actual planet. And all of this pressure then generates earthquakes, and some of the biggest ones were actually inside these fractures right here that you see on this beautiful picture. These are actually called Cerberus fossa, and all of the biggest events happen in this region, very close to the biggest volcano. And because of these observations, scientists deduced that inside of Mars, basically the internal parts of Mars, are much more fractured than Earth and even the Moon. And the fracturing probably happened because, well, first of all, Mars no longer has any activity on the inside, or at least not enough, and also because of the actual shrinking of the planet. Basically, as the planet cools down, it seems to shrink in size, which also increases the frequency of various earthquakes. At least this is how the scientists currently explained the unusual frequency of these earthquakes on this planet. But the internal structure of Mars and of course earthquakes are not the only findings. The scientists also realized that there are a lot of other strange things happening on the surface of Mars that we didn't really expect. During its mission, the InSight probe detected these unusual pressure changes, suggesting that this passed overhead. This is what we refer to as the so-called dust devil. We've seen quite a lot of pictures of them from the orbit of Mars, and we've also seen a lot of various effects that are left by the dust devils as they move across Martian surface, but we've never really caught one in action except for maybe once with Curiosity probe. Specifically here in 2017, we may have kind of witnessed it and were able to take a picture of it, but so far they've been invisible to us. Here once again you can kind of see something moving across the screen. It's very difficult to see, simply because these dust devils are for the most part really thin in terms of the actual pressure changes. Martian atmosphere is not very thick, so it would be very difficult for these objects to actually produce similar effects to, for example, a tornado here on Earth. But they still have some effect, and this was detected by the probe. And it didn't just find 1 or 2 or even 10. It was able to detect thousands of them, meaning that there's actually a few of them every single day passing close enough to the probe where it actually can detect them. And so if we do end up going to Mars one day and possibly even starting a colony there, we do need to be aware of these potential problems. Another really unusual discovery was in regards to the magnetosphere of the planet. We've actually previously measured the magnetosphere of the planet from the orbit using probes like, for example, MAVEN, and we had a pretty good understanding of what the total magnetosphere of Mars was. But when the InSight probe did it again using its own magnetometer, it discovered something completely different. The actual magnetosphere on the surface was about 10 times stronger, or at least the magnetic part was 10 times stronger than we thought it would be. And this is something we can't really explain just yet. Currently we think that maybe these magnetic effects are coming from underneath the probe, from the actual magnetized rocks where the probe is located. But as of today, there is really no good answer how the magnetic forces on the surface are about 10 times stronger than what we believe them to be. In other words, there seems to be a magnetic field on the inside, and it's created by something and it's being maintained by something, but there is really no good explanation on how deep it is and what's really making it. Because as I mentioned before, we don't really detect this from the orbit, so it's something coming from within. And what's even more unusual is that these observations seem to actually vary between day and night. And for some unknown reason, they also seem to pulse right around midnight. So there's really no good explanation to what's happening yet, but it's definitely something scientists really want to investigate in a little bit more detail to understand what's going on here and what's causing these unusual effects. One potential explanation is that this is some sort of an effect from the solar winds striking the surface of Mars, which is why it's dependent on day and night cycle. But this is just an assumption and there is no definitive explanation just yet. And to try to explain this, we actually have to investigate the Martian core in a little bit more detail and take a look at what's happening on the inside to see if it's actually something that creates magnetosphere down there. And the last discovery coming from this mission, at least as of today, are the sounds of the Martian surface. Now unfortunately, if you were to just stand on Mars and try to listen, you would not really hear much. Some animals would because it's so-called infrasound, it's basically really low frequencies, roughly around 10 Hz or so in frequency, but because we can digitally process the sound to be heard, this is roughly what all of this sounds like if you were to stand on the beautiful surface of Mars and if you were able to perceive these sounds. And here's what all of this sounds like. This is from the video you can find in the description below, released by NASA itself, and the sounds you're about to hear are essentially the Martian wind. Which is actually somewhat similar to what I thought it was going to sound when I made a video what your voice might sound like on Mars. You can check it out somewhere above my head. Anyway, so that's all we know about Mars and the mission called InSight, but once we discover more and once NASA releases more information, I'll make sure to follow this up with another video. I'm sure there are going to be a lot of other exciting discoveries coming from this planet, and hopefully it will help us understand what actually happened to it and how to avoid that happening from here on Earth. Hello wonderful person, this is Anton, and today we're going to be talking about the possible origins of life and a new discovery coming from Japan of something really strange in one of the meteorites. So in the last few years we've been making a lot of really interesting discoveries, including this right here. This is a recent publication from Nature where the scientists discovered that certain bacteria will actually make these beautiful patterns when you mix them together, and they sort of resemble flowers. But despite all of these amazing discoveries over the last few years, we're still not entirely certain how to answer the question of how exactly did life form originally on the planet? There are two major theories, but neither one of them is definitive just yet. One of the theories suggests that the life sort of spontaneously appeared on the planet as various chemicals interacted with one another and formed various organic compounds, while the second theory speculates that it's so-called panspermia, or at least partial panspermia. In other words, the meteorites and asteroids delivered a lot of various compounds to the planet, which then led to various chemicals interacting, and because these asteroids would also create a lot of energetic events as they collide with the planet, all of this together eventually led to the formation of early life. But trying to identify the exact origin of life is still not really that easy. Now, one of the more famous experiments of the 20th century was actually this right here. This is the so-called Miller-Urey experiment. And in this experiment in 1959, I believe, the two scientists decided to try to simulate early Earth conditions, and by using these early Earth conditions, they were then able to spontaneously generate a lot of various materials that technically are part of life today. So essentially they were able to produce organic materials by creating chemical reactions that could have been similar to early Earth. And in the last 15 years, two more major experiments were conducted to generate, or to actually successfully generate, even more of various amino acids that technically are part of life. So in other words, even though not everything was generated in this way, these experiments provide enough evidence to suggest that life could have generated on Earth spontaneously through various chemical interactions. But then we also have a lot of evidence coming from the asteroids and various meteorites that were recovered here on Earth that suggests that a lot of other organic compounds and of course amino acids could have come from outer space. In other words, delivered by various meteorites. So in that sense, we're still not entirely sure where all of these materials came from and what triggered the formation of life. I guess before we continue, let's define what life really is. Well, if you were to look at the so-called tree of life, which is actually a huge connection or network of various types of genomes that all connect to the common ancestor, and as you can see here, this tree of life even shows us how big the genome of every organism is. For humans that are right here, our genome size is about 22,000, and it's actually not even the biggest of all of the other organisms. But anyway, so everything on our planet Earth is in a sense connected through this tree of life. Everything that we consider to be life, and even viruses that we don't technically consider to be life, have certain genetic components, and more specifically, pretty much everything that we consider to be life has what's known to be RNA. Now, not everything has DNA, and as a matter of fact, there were several studies trying to discover how many different organisms out there don't have DNA at all, but everything does seem to have this molecule on the left, which is RNA, and even though it is somewhat similar to DNA, it is a little bit different. Now, we're not going to go into too much detail explaining the difference between them, but they are connected and related, and many scientists today believe that RNA appeared first on the planet and very likely then led to the appearance of the DNA. And because viruses in general are able to very actively propagate and replicate using RNA, as do certain other organisms as well, today we understand that finding the origin of RNA will definitely help us answer the question of how life was formed on the planet. So what exactly did the scientists discover in this recent study? And how does this all relate to the origin of life? The Japanese scientists behind this paper that you can find in the description below used these samples from two very famous meteorites discovered on the planet. This one right here, known as NWA801, this is found in North Africa, and the so-called Murchison meteorite discovered in Australia, both of which have already been used for studying and discovering a lot of other things about the origin of the solar system. But the scientists behind this paper discovered a tremendous amount of various organic compounds, but most importantly, the sugar known as ribose in these meteorites. And ribose is the R part of RNA. Now, unfortunately, it wasn't deoxyribose, which is the D part in DNA, but discovering this suggests to us, or implies to us, that a lot of this ribose originally could have come from outer space from various meteorites. And this, once again, encourages the idea that a lot of the materials on early Earth that then generated life on the planet possibly came from outer space after all. Or maybe it was actually a combination of both. So because we know that many collisions did happen quite frequently on our planet, especially during the period known as the late heavy bombardment, all of these collisions could have delivered a tremendous amount of various materials and also generate a lot of various energetic chemical reactions that then essentially led to the development of early life on Earth. Now, of course, all of this is still very speculative, but the discovery of ribose inside meteorites is a huge step in trying to identify not only how life forms here on Earth, but also how life may have actually formed on other planets that one day we might be able to discover somewhere out there. And since many other compounds have already been discovered in meteorites as well, including various nucleotides and various amino acids, that are essential for life and that every organism on the planet uses today as well, these new discoveries definitely gave us a lot more evidence to support the idea of panspermia, or the delivery of organic materials here on the planet through extraterrestrial means. And this, of course, is actually great news, because this also means these rocks could have landed on other planets, including Mars and Venus, and very similar situation could have occurred in other star systems as well. If things like ribose and a lot of other amino acids are actually common everywhere in our galaxy, we might be able to discover a lot more of these unusual exoplanets out there in the galaxy that could have had very similar conditions and thus similar reactions that led to some kind of a primitive life. Now today we don't really know exactly what other features of our planet make it so unique that it seems to be the only world so far where we know as a fact that life can exist, but once we understand how life was generated on our planet, we'll be able to answer all of these questions, hopefully within the next few years. But the reason I'm saying a few years and being so optimistic about it is because in a few years, the samples from asteroid Bennu that you see right here, and also the samples from asteroid Ryugu will have returned to our planet, and both missions will have hopefully accomplished their main goal of bringing samples back so we can actually study them in a lot of detail and discover what these early asteroids have in them, and could they have brought all of the materials to the planet in order for early life to begin. Chances are that what we're going to discover is finally going to be able to provide the answer for us. But for now, I guess it's a bit of a mystery of how Earth became habitable. One thing that's certain though is that this ribose that was discovered in the asteroids is not a result of some kind of a contamination, because once they analyzed ribose discovered in those rocks, they identified that most of the ribose was made out of the much rarer carbon-13 as opposed to carbon-12 that we have here on the planet. Carbon-13 is normally generated in very energetic events, and specifically in many cases it is an indication of cosmic events. So because carbon-13 ribose is relatively rare on Earth, the scientists behind this paper were quite confident in saying that it definitely came from outer space. But for now, unfortunately, that's all we know. Once Ryugu and Bennu return samples to us, we'll be able to understand a little bit more. Hello wonderful person, this is Anton, and in this video we're going to be talking about what our solar system may actually look like from the outside. And even though for the longest time we believed it sort of looked like this, with the heliosphere forming this unusual comet-like formation, some of the new studies think that the actual image is more similar to what you see right here. A very unusual and a very peculiar shape that is kind of difficult to describe. So we have a pretty good idea of what planets look like. We also have a pretty good idea of what some of the solar system looks like from the outside. Specifically here, if we were to move out to the point where the Neptune orbits, we do have a good understanding of that particular shape. But the thing is, the solar system is technically defined by the so-called heliosphere, which scientifically is defined as the sphere of influence of our Sun. Normally, this sphere of influence is created through various magnetic interactions, specifically through the release of the very strong solar winds, and a lot of other particles from the outside interacting with the particles coming from within. So in some sense, this is kind of what we believe the whole thing looks like. And the thing is, both Voyager 1 and Voyager 2 probes left this particular heliosphere and are now traveling in the so-called interstellar space. And this is why we finally were able to actually start analyzing the shape of this heliosphere and even try to understand what's really happening on the inside as opposed to the outside. You may have already seen the video I made previously about the Voyager probe, and more specifically Voyager 2, which is somewhere right here in the location in the solar system, actually just outside of the solar system. And as Voyager 2 was leaving the heliosphere, it discovered that there was a lot of really hot plasma. I referred to this back then as a kind of a firewall, because technically fire is also plasma, and so essentially these really hot particles are extremely unusual and they're present right here in front of the heliosphere, forming a kind of a, well, firewall. And all of this is actually formed because the solar wind, as it's being expelled from the sun, creates a kind of a pressure right in front of the sun as it travels across the galaxy, and the interaction between the particles from the outside and the particles from the inside do create this unusual phenomenon in front. But the thing is, there's not a lot of particles here. Usually there's approximately 1 particle per cubic centimeter, which is about this big, so these environments are really low in density. But this here is a little bit more dense, and the area within the heliosphere is also a lot denser as well. So it's kind of like an interaction between higher density and lower density regions, while at the same time the interaction between different types of charged particles. And we also understand that heliosphere is pretty much essential to the survival of life on our planet. It does protect life from a lot of cosmic rays from outside of the solar system that would actually most likely increase the radiation on our planet dramatically. But because of the heliosphere, we're protected and sort of sheltered from all of this dangerous radiation from outside. And in terms of the actual distance to, I guess, the border of heliosphere, it's approximately 120 astronomical units, which is about 3 times the distance of Pluto to the Sun. Or I guess 120 times the distance of Earth to the Sun. So it is pretty far away, but understanding this heliosphere and of course its shape is really important when it comes to understanding solar systems or star systems, and also just in general the interaction between various really highly charged particles, and of course how all of this relates to the protection of our own planet. But for the longest time we always believed that the actual shape was more comet-like. Basically sort of like this, and a lot of this evidence came from other stars. For example, this is what one of these stars looks like if you were to look at it from here, from Earth, and it does seem to appear like a comet-like environment. Basically, you get a comet-like shape and this unusual formation in front of it, which is formed by the star's heliosphere. A somewhat similar example can be seen right here, near the star known as LL Orionis, and you can kind of see that it does seem to form this comet-like formation as well. But I think one of the best known examples is the star known as Mira, where you can definitely see how comet-like it seems to appear. And the thing is, we've always believed that this is pretty much what solar system would have as well, which is why all of the NASA analysis always sort of makes it this kind of a shape. But turns out that we might have been wrong, and mostly because of some of the more recent observations from other probes, like for example Cassini and New Horizons. And it all began with the analysis of data from the Voyager probes, and essentially back in 2015, using a lot of data from the Voyager probes, some of the scientists were able to emulate what the potential heliosphere looks like, and the shape that they got was actually this. It was a little bit more of a crescent than a comet. And even though it still sort of resembles a comet-like formation, it's really more of 2 very specific, very unique shapes on 2 sides. So in other words, right in the middle there was pretty much nothing. The heliosphere sort of ended right here. And this model was not really well received at first because it didn't really add up with some of the other information we had. Because a few years later, the Cassini probe was able to create another model, and that model seemed to predict that the actual shape was almost perfectly spherical. And in some sense this contradicted the first assumption. But now we have even more data, and this time it's from the New Horizons mission that is technically still inside the solar system, but it's on the way out, and it's already been able to collect quite a lot of various data in regards to heliosphere as well. And the main difference between this new model and previous models is that it actually made a really interesting assumption. It essentially divided all of the charged particles that it was able to detect into the ones coming from within the solar system and the ones coming from the outside. Before that, we kind of just assumed that they were all the same, but now we know that they're not. They're actually coming from 2 different directions. And some of these particles that are coming from the outside could also be neutral at first. They actually might have no charge, and because of the interaction with the heliosphere and the sun and other cosmic rays, might eventually become charged with time. And the main discovery of the New Horizons mission is that these external particles that were captured from the outside of the solar system eventually become much hotter and much more energized before essentially, I guess, turning around and then following the solar wind on the way out of the solar system. So in other words, there's a very interesting interaction between the external and internal particles, and they do create these unusual, well, technically current-like formations, which is essentially the unusual shape that you see right here. These unusual currents are formed through the interaction of different types of charged particles as they essentially move around the heliosphere, and then slowly get carried out of the solar system completely. And so by modeling two different types of particles, the researchers behind the paper you can find in the description below discovered that it probably resembles something like this. Basically a combination of a perfect sphere that we detected previously and a crescent shape that we also detected previously as well. In other words, it's a combination of two, and it does seem to reconcile both theories pretty well. With the only major difference being that inside of the sphere, we'll find two different types of particles at least. So some of the cooler particles coming from the solar wind, and some of the more hot particles that came from the outside and got charged by the solar wind and are now being carried out. And even though this is just a model for now, we're not entirely sure if this is exactly what it looks like. This will definitely give us a reason to kind of zoom in a little bit more to some of these other stars we're looking at and try to identify if something similar is happening in there as well. Mostly because we believe that this interaction between the heliosphere and of course the external particles that are coming from outside of the solar system are absolutely essential for an ability of a solar system or a star system to maintain at least one planet similar to planet Earth and its ability to actually be protected from the radiation from outer space. In other words, the heliosphere is absolutely crucial for having habitable planets, and we think that studying heliosphere and understanding what makes the solar system so different is really important for us in trying to find other stars that might actually have similar planets. Because today scientists still think that our solar system is a little bit weird compared to everything else. And maybe having a different heliosphere is actually one of these unusual phenomena that other stars also don't have. So this is something we want to learn a little bit more about, just so we can look for other stars similar to our Sun. But unfortunately, except for this model of this shape right now, that's kind of all we know about our own solar bubble. Once we discover other stars that have their heliospheres visible, and once we can compare them to some of the other discoveries we make in the next few years, I'll make sure to follow this up with another video because this is a very important topic for the discovery of other habitable planets. And also, I'm sure as different probes such as the New Horizons probe also end up leaving the solar system and past the boundary of about 120 astronomical units, essentially leaving the heliosphere, we're going to be able to discover even more things about this strange and unusual shape of the bubble we live in. Hello wonderful person, this is Anton, and in this video we're going to be talking about the surface of our Sun, and more specifically, why is it the Sun kind of looks like this? It sort of looks like popcorn, and it makes me really hungry. Now, a few weeks ago from when I'm making this video, the beautiful picture that you just saw was released by several different observatories, including the National Solar Observatory, whose telescope was used to take the beautiful and extremely detailed picture. Now, after the picture was released, a lot of people were actually asking me, so why exactly does it really look like this? What's going on here on the surface? And the thing is, when the picture was released, a lot of people were asking me to make a video about it, but there was really nothing much to say. It's a beautiful picture, but there was very little I could talk about. Until several of you wonderful people left a comment saying, but why does it look like this? What's really happening here? What's with the popcorn look? Why does it look like I want to eat it? And so this is why I decided to create this video briefly explaining what's happening on the surface of our Sun and of course other stars, and why it looks like such a peculiar structure that seems to be moving and churning all over the place. Now first of all, let's actually take a look at this simulated star right here. This is a K-type star, slightly less massive than our Sun. We're going to zoom into it and see if it has these cells as well. And here, if I approach it really closely, you'll see that it also has these unusual cells, although these ones are not moving because it will be really difficult to simulate all of this. And you'll find very similar effects simulated right here in Universe Sandbox. If you zoom into a star, you'll notice that it does have somewhat interesting moving cells as well. But interestingly, if the star is much bigger, like for example, let's just take a look at Betelgeuse, because it's the most famous star of the year, here these cells are much larger in size. So something similar but a little bit different is happening on the surface of larger stars. And just so you know, we've actually seen these cells by looking at a very far away object using really powerful telescopes. So we know that larger stars do have larger cells. And so in a nutshell, each of these objects is what's known as a convection cell. And each one of these cells here on the surface of the Sun is actually really large. It's a few hundred kilometers, or I guess a few hundred miles across. Here the National Science Foundation used an image with Texas and a very large city sort of represented by this little dot and also this square. So just so you can see the size of each cells in comparison. And although their size can be up to about 1500 kilometers in size, they usually last anywhere from about 8 to maximum 20 minutes and then disappear as they're being replaced by other cells nearby. So this is a very active process and it happens from within the sun. And what each of these represents is a kind of a column that we're looking at from top. And these columns are basically these huge plasma formations, with the surface of each column being the plasma cell we're looking at. In much simpler terms, it sort of looks like this, with this being the cell we're looking at and the column going down. But in more realistic terms, it gets a lot more complex on the inside. And so in a nutshell, as the hot plasma from within the sun, because obviously that's where the heat is coming from, starts rising to the top, the cooler plasma that's on top starts sinking to the bottom, forming these ridges that we see as these black lines all over the place. So basically the middle, the brighter part, that's the hotter part. The darker part is the cooler part. And so we're really looking at two parts here. We're looking at these cells on the surface. These actually have a name. They're called Rayleigh-Bénard cells, or sometimes just Bénard cells. And the best example can be seen in a typical kitchen. Here are these cells forming as the actual heat difference on top and on the bottom creates these cells naturally. So for example, if you've ever boiled milk, you might have seen these form as well. And because both buoyancy and gravity are responsible for the formation of these cells, they also have a kind of a 3D component, which is of course the column I previously mentioned. And these thermal columns are very complex. One of the easier examples here on Earth is usually in regards to various weather formations. For example, things like hurricanes form in a similar manner as well. But the complexity of what's happening inside the sun is on a completely new level. So each of these cells has its own column that sort of lasts for a little bit and then disappears, being replaced by other columns and other cells. And one of the better simulations I was able to find of this is by a wonderful person named Christian Huttig, who created this Martian simulation of what Mars may have been like billions of years ago. And here you can see both the columns and cells interacting with each other. And this is essentially very similar to what's happening on the sun and how these convection cells form as well. And although on average our sun has approximately 4 million of these cells at all times, there are also other bigger cells underneath them. And so there's actually a very complex, very unique 3D structure inside our sun with much larger cells on the bottom, with some of them actually being responsible for the creation of various magnetic effects as well. Although these cells, the much smaller cells that you see here, are not actually responsible for any kind of magnetism. These are just the interaction of gravity with buoyancy and heat exchange. So this is more of an effect, not really a cause. And the much larger granules on the inside, basically underneath the upper surface of the sun, can actually last up to about 24 hours and be approximately 30,000 kilometers in size, or at least 20 times as big. So there are actually several layers and they do interact with one another. But we'll actually talk about all of these other inner parts of the sun in some of the future videos because it's a pretty complex topic. Nevertheless, it's pretty awesome to see how much our science has advanced in the last 20 to 30 years and how accurate our pictures have become. Not only do we have a picture of a black hole, we also have an extremely detailed picture of our own sun, taken from here on Earth. And as the time goes by, hopefully our telescopes get even better and we get to discover new mysteries of the universe. Hello wonderful person, this is Anton and welcome to Uranus. Not Uranus, because that's not really how you pronounce it. Also because of what we're going to be talking about, and because I don't want you to make fun of this video. So yeah, we've discovered that apparently Uranus is creating a lot of really unusual gas clouds. And these gas clouds are generated in a very unusual way and suggest that this planet has actually lost a lot of mass over the last few billion years. And let's begin right here, a little bit of history. The year is 1986, January of 1986, and the Voyager 2 probe is about to approach Uranus and collect a lot of different data, including magnetic data, for the first time in history. Actually, for the only time in history. We haven't really been back in over 30 years. Uranus, being one of the stranger planets in our solar system, as you can see, is actually orbiting on the side. And this is not the only discovery we're going to be making here. We're also going to discover a lot of its moons. We're going to discover that it has rings, as you can see. They're kind of difficult to see in this simulation, but if I raise the brightness, you'll see them pretty easily. And we also discovered a lot of other things. But there is one thing that we discovered that we didn't really know about yet. Mostly because it's not something we knew existed. And this something is known as plasmoid. So, in a nutshell, if you were to kind of get the idea in a single picture, here is a plasmoid. We've discovered these around Earth, we've also discovered them pretty much around other planets as well, but the biggest ones we found so far were around Jupiter and Saturn. Both Juno and Cassini mission discovered really large plasmoids, which are in a nutshell kind of like gas clouds of various material, but usually hydrogen, ionized hydrogen, that slowly leaves the planetary system and escapes into the rest of the solar system, most likely just becoming gas. But to try to understand what plasmoids are, we have to understand what magnetic reconnection is. Here's an example from the Sun. In a nutshell, magnetic lines that are formed around all magnetic objects, including our Sun and our planet Earth, eventually will snap and try to reconnect, releasing a lot of energy, while at the same time causing some of the mass, and in the Sun's case it's actually the extremely energetic and extremely powerful solar wind, be released as a kind of a blob of ionized matter that travels across the solar system and sometimes collides with planets, including planet Earth. And we usually refer to these as a magnetic storm. But not just Sun does that. Pretty much any object that has magnetic field will create very similar conditions and very similar phenomena, but on a much smaller scale. So for our planet Earth, when the magnetic line reconnect, it will also actually release some of our atmosphere as a kind of a tiny small plasmoid that will travel across the solar system. And really mostly because the magnetic line reconnection happens all the time. And the more magnetic field the planet has, the larger plasmoids it's going to form, which in a nutshell are nothing more than really just big bubbles of gas that's trapped inside the magnetic field that slowly move away from the planet and probably collide with other stuff. But here's the thing though, we still really understand very little about these plasmoids because we discovered them not so long ago, and we've mostly seen them only around Jupiter, Saturn and Earth. We know they exist around other planets, we just didn't get a chance to detect them physically. And for example, this paper from 2015 discovered approximate mass of these bubbles for both Jupiter and Saturn, and most of the composition of these bubbles did not just come from Jupiter itself, but also from various moons, like for example Io, that does have a tendency to create rings around Jupiter, which then has all of these particles that orbit around Jupiter and are trapped by the magnetic lines of the planet, which then create plasmoids with all sorts of materials on the inside. And unfortunately, currently we don't even know how massive they are, we only have approximate estimates, or where they end up afterwards. We know very little about them. The approximate mass for a typical plasmoid around Jupiter, which usually occurs at least once a day, is anywhere from about 1 to maybe 10 million kilograms, with something very similar forming around Saturn as well through the interaction of plasmoids with the emissions from, for example, Enceladus that we've discovered emits quite a lot of various particles into the area around Saturn and essentially creates another ring as well. So all of these plasmoids seem to contain different composition, they also seem to be different in size and mass, and for the most part their frequency of how often they're produced depends on the strength of the magnetosphere and the actual amount of magnetic reconnections. But 34 years ago, as Voyager 2 was flying through the area where Uranus is located, it was able to detect another plasmoid, and completely by accident. Back then, because we didn't know plasmoids existed, we kind of ignored this data. But one of the recent scientific papers that you can find in the description below decided to investigate some of the magnetic phenomena we discovered around Uranus and also compare some of the previous discoveries with what we know about other planets. And to their surprise, when they tried to create the model for the magnetic field around Uranus, they discovered this unusual pattern that looks like a zigzag in the magnetic field that is actually a telltale sign for a relatively large plasmoid that the Voyager probe passed through on the way to other planets, on the way to Neptune actually. And so this was actually a pretty incredible discovery because this is a data that's about 34 years old, but back then we had no idea that this was something important. Today we know that this is a plasmoid, which actually indicates, well, several major things. First of all, this shows us that Uranus is also losing a lot of mass through these plasmoids, and because its magnetic field and also its orbit is very different from anything else in the solar system, pointing in a different direction around 60 degrees from the actual orbit itself, this may imply that Uranus could be losing a lot more mass a lot faster, even compared to planets like Jupiter and Saturn. And in terms of the actual size, it very likely resembled something like this, so it was a pretty large object, around 100,000 or so kilometers in radius. Although shape-wise they believe it was very likely similar to a cylinder, not really a sphere. And in terms of composition, this was mostly ionized hydrogen, which is of course what the planet itself is made from, so it wasn't really anything unusual like you would find around Saturn or Jupiter. But the most important implication here is that it seems that Uranus, over the period of few billion years, very likely lost a huge percentage of its atmosphere. As a matter of fact, it may have been 15 to 55% more massive in the past, which means that it may have been much larger as well. Now, right now, this is just a speculation. Obviously, we would need to go back to Uranus and study it in a little bit more detail to discover if any of this really makes sense. But considering we know so much about plasmoids from Jupiter and from Saturn, and considering we know that Uranus does seem to be a little bit odd when it comes to magnetosphere, and probably also when it comes to these plasmoids as well, I think it's fair to say that it's not a really far-fetched assumption that this planet used to be more massive and much larger when it was just created. And this is, in some sense, the nature of magnetosphere as well. It does protect planets from losing atmosphere, but at the same time, it also seems to cause planets to lose a lot of atmosphere. And modern studies suggest that this is exactly how Mars lost all of its atmosphere as well. It was very likely through the combination of being stripped by the sun itself and through magnetic reconnections that caused a lot of different plasmoids that eventually had Mars lose all of its atmosphere, turning the planet a lot less hospitable. And since today we know that the magnetosphere is essential for planets, and it also seems to help planets transform in a variety of ways, this of course creates a lot of questions and a lot of mysteries for us to try to study and try to understand. And this new discovery also gives us another reason to go back to Uranus and try to study it in a little bit more detail. Because for all we know, this could have been a much different planet in the past, possibly even a lot more massive than we imagine right now. And this could also explain a lot of other anomalies we're observing in the solar system. And just in general, studies like this do actually help us understand how these plasmoids affect and evolve various planets and their atmospheres. And more specifically, this is of course really important for our own planet Earth. Our planet depends on its magnetosphere, and it also creates these plasmoids. So understanding what happens to a lot of this material and where it ends up eventually is also really important for us. But when it comes to various exoplanets, we do need to understand how these plasmoids interact and evolve planets in general. Because we really want to find more planets similar to Earth, not similar to Mars. And we know that plasmoids played a really important role in turning Mars the way it is today. A not so habitable planet. A planet that we would actually need to terraform to make it habitable for human or any other life. But for now, that's all I wanted to mention in this video. You can check out the paper I mentioned in the description below, or you can read more about this from this link right here, the summary provided by NASA. Either way though, it's a really exciting discovery. It's kind of fun to hear about something new we discover in old data, something we didn't really know about. And it's also kind of fun to talk about planets we normally ignore or don't really talk about much. Unless of course it's some sort of a joke related to the name Uranus. Which is actually not a joke at all, because that's really how the name is pronounced. Hello wonderful person, this is Anton, and in this video we're going to be talking about a discovery of a very unusual asteroid that seems to be one of the closest asteroids to our Sun, and it's also really massive. So in some sense, it could be potentially dangerous to Earth as well. So the asteroid we're looking at right now is actually known as Atira. By definition, all of the Atira asteroids are always orbiting within the orbit of Earth. In other words, they are kind of like the inner belt asteroids. Currently, this is the smallest group of asteroids known to us. There's only about 21 of them that's been discovered so far. But all of them are also really large. As a matter of fact, they're all within about 1 kilometer in size, and in some cases might potentially cross orbits with Earth as well. So in other words, a lot of these asteroids are actually kind of dangerous. And the main reason is not only because they orbit so close to our planet, but because when we're looking for asteroids, it's very easy for us to see asteroids that are away from the Sun, mostly because we're looking at dark space. But all of the asteroids that are orbiting close to the Sun are very difficult for us to detect, because basically the Sun is kind of covering most of them. In other words, in order for us to detect anything in this region, we always have to look at these asteroids during twilight, basically at dawn or at dusk, when the Sun is not too bright, so it allows us to kind of see some of these asteroids in the night skies. And to do this, a lot of specialized telescopes have been developed, and we also rely on a lot of automatic systems. One of such online systems is known as the Virtual Telescope. It's basically a remotely controlled telescope that's controlled via the internet, created by the discoverer of this new asteroid, an Italian researcher by the name of Gianluca Messi. And as you can see from this picture, he got really lucky recently and discovered this asteroid that you see on the screen. This is currently known as 2020 AV2, and 2020 is obviously the year when it was discovered. And what makes this asteroid very unusual compared to all of the previous Atira asteroids is that it seems to be actually within the orbit of Venus. In other words, it seems to always orbit within this circle here, approaching Venus and Mercury once in a while. This also currently makes this asteroid the second closest asteroid to our Sun, slightly beat by the previous discovery from 2019, the asteroid 2019 LF6. But unlike this asteroid, the new discovered asteroid does not have this eccentric orbit. As a matter of fact, from all of the so-called Atira asteroids we've discovered, most of them seem to possess very eccentric orbits, and some of them even have eccentricity that's nearly 97%, making it some of the most eccentric objects in the solar system except for certain comets. Now, a lot of them actually leave really far, almost reaching Jupiter, and then come back close to the Sun. But unlike all of these other eccentric asteroids, what seems to be unusual about the new discovery is that its orbit is a lot more circular than other asteroids. Here, the eccentricity of 2020 AV2 is only about 17%, and it basically kind of goes in between the orbit of Mercury and the orbit of Venus. But the thing is, it also never really approaches either planet really close. The closest distance that it gets to is about 10 million kilometers, which creates a lot of really interesting questions. One of them is, of course, how did it even get here? What caused this asteroid to assume this orbit? And the second question is, of course, well, we think that this is not a stable orbit. So what is going to happen to this asteroid eventually? The current size estimates suggest that this is anywhere from about 1 to maybe 3 kilometers in diameter, making this a relatively large rock. And if you've watched some of the previous videos, you might also remember that in the last year we've discovered at least 3 craters on our planet that were created by rocks that are very similar in size to this. The most recent discovery, coming from the Lao, of a large crater that's about 15 kilometers in diameter was actually created by something similar to this. This, of course, doesn't really give us any comfort because it just means that these rocks are still out there, a lot of them do collide with our planet, and one of them might eventually make its way toward Earth and collide with it as well. Although currently we don't think that it's going to be this specific asteroid. As a matter of fact, it has a much higher chance to collide with Venus right now than it does with planet Earth. But the other major mystery is, of course, in regards to its low eccentricity and the fact that it never actually crosses the orbit of Venus. It never really comes close to orbit of Earth at all. What exactly caused it to have such an unusual orbit? And more importantly, are there other asteroids that are similar to this somewhere else hiding in this region? And this is, of course, a very important question for us to answer because we need to understand how these asteroids form and what makes them assume these orbits. These Atira asteroids, or I guess in some sense you can also call them the twilight asteroids because they can only be visible when it's twilight on Earth, are probably some of the more dangerous asteroids out there. And the two main reasons are, of course, that we can't really see them very easily. They can come from out of nowhere. And the second reason is because they get to approach both Venus and Mercury much more frequently. A single year here only takes about 150 days, meaning that every 150 days this asteroid has a chance to slightly shift its orbit, and then that orbit can accidentally cross with any of the planets in the solar system. And since we've already found 3 different craters on the planet that were created by similar asteroids within the last 3 million years or so, this kind of makes it really important for us to understand. Could these craters have been created by these unusual Atira asteroids? And obviously if the material here matches to the one on the planet Earth, then it's very likely that these are the main culprits behind all of the collisions. Maybe these asteroids are the ones we should be actually watching more carefully. So all of this is really important for us to understand in order to basically protect our own civilization. On the other hand, we also would like to find out how many of these asteroids are located in these regions. It's very unlikely that we're going to discover something similar to an asteroid belt with hundreds of thousands different asteroids, but nevertheless there could be a lot of rocks hiding in this region, many of which could potentially be dangerous to planet Earth as well. But one of the more immediate mysteries is of course in regards to its unusual orbit. It's the only asteroid that has such an unusual low eccentricity orbit that doesn't really come to any major planet, which means that we need to study this in a little bit more detail. The only current explanation for how it got its orbit is by possibly passing next to some sort of a planet, possibly even Jupiter, which took it closer to the Sun, and then through the action of the so-called Kozai mechanism, which I explained about 4 years ago in the video that you can find somewhere above my head right now, the orbit of this asteroid eventually shifted, making it look the way that it does today. But I guess the scary part here is that Kozai mechanism never stops acting. As a matter of fact, it's very likely going to shift the orbit again with time, suggesting that at some point the asteroid will either get a much closer orbit to the Sun, or it might actually increase its eccentricity once again and start crossing planet Earth's orbit, which is something we don't really want asteroids to do. And I guess if we're lucky enough, this asteroid will one day hit another planet, but at this point it's probably going to be either Mercury or Venus. It's currently not really estimated to hit anything, but if the Kozai mechanism shifts the orbit of this asteroid enough, it will definitely cross the path with one of the planets, creating a relatively large collision, which we could then of course use to study what happens when these asteroids collide with planets like Earth. Hopefully by not actually having it collide with Earth, of course. Currently, our understanding of the effects of asteroids on planets is actually not really that advanced. We know they do something to the climate, for example, we're just not entirely sure what. And we know many collisions have happened in the past. So by using other planets as a kind of an experimental box or experimental lab, we'll definitely be able to understand the effects of asteroid collisions and of course learn to prevent them in the future as well. But on that note, that's really all we know about this unusual discovery for now. It's a very strange asteroid, we definitely want to learn more about it, but since it was just discovered, there's nothing else to say. Hello wonderful person, this is Anton, and we've just discovered a lot more of these so-called trans-Neptunian objects similar to the beautiful Pluto. In other words, Pluto has now officially gotten a lot more siblings and cousins to deal with. Now the first so-called TNO trans-Neptunian object was of course Pluto, but then it actually took until 1992 for us to discover another one. These are really difficult to see objects, and this right here is one of the more famous ones. This is known as Haumea. It also is one of the few objects out there that not only has rings, but also has several moons as well, even though its size is not particularly that large. But the most famous is of course Pluto and its partner Charon. Although in terms of size, Ares is actually relatively similar as well, although this is what Haumea looks like in comparison. So over the past few decades, but more specifically really in the last few years, we've discovered really lots of them. And now the scientists whose paper you can find in the description below discovered a lot more using a really brilliant method. But just to give you a definition of what TNO is, essentially it's an object that orbits past the orbit of Neptune. If we were to look at all of them we've discovered so far, there are actually quite a lot. Close to about 3,000, but for the most part they're actually really tiny. And because they're so tiny, they're also very difficult to see. And obviously some of the farthest objects in the solar system are also so-called TNOs, with some of the more famous ones being objects like Eris and Sedna. And so far we've discovered that almost all of them kind of have very similar composition. They also more or less have the same color. They have relatively similar size and mass, or at least density. But in some cases they do get to be large like Pluto, and in other cases they get to be really small as well. So we've already discovered some small ones, but now trying to discover even more of them has actually become a challenge, mostly because they either are really difficult to see, they don't really reflect that much light, and in some cases they're actually so far away that there's just not enough light to reflect at all. And in many other cases they're just a little bit too dark. So different techniques need to be used to try to discover more of these objects. And so the scientists behind this paper actually did just that. They've used a very interesting observatory located right here in northern Chile, and you're going to see it in a few seconds as we zoom in on Google Earth here. And essentially this observatory has a lot of different projects going on, but one of them is to look at various phenomena around the universe, not just our solar system, the universe, and actually analyze what could potentially be dark energy. The observatory, known as Cerro Tololo, although I'm not sure if I pronounced this correctly, is located on a relatively tall mountain in Chile because we want to have as little interference from air as possible. And one of the projects that was just finished last year is the so-called DES, or Dark Energy Survey. And the main purpose of this was to look at a patch of the night skies for approximately 5.5 years and to try to capture as much data as possible in regards to things like, for example, supernova, things like gravitational lensing, various galactic clusters, and the main purpose was to actually try to identify as many of these sources as possible so we can actually finally learn a little bit more about the mysterious dark energy that seems to be causing the continuous expansion and acceleration of the universe. But when the scientists were looking around at various results from this telescope, they realized that it also seems to be detecting various objects in the solar system. Now, they were looking at a patch of the night skies of about 70 degrees by 70 degrees. So essentially, that's about 4% of the entire night sky in general. And also, this is in the southern part of our planet, so in the southern hemisphere, meaning that they were looking into the southern night skies. But even in that particular part of night skies, they were able to discover a lot of new stuff. And more specifically, just in this study, they were able to identify over 300 different objects in our own solar system, many of which we already knew about, so this was kind of a confirmation that this technique seems to be working. But many others were completely new to us, and specifically they believe that they found about 139 new objects that were never seen before. And one of the ways that they were able to identify all of these objects is, of course, by looking at various types of motion detected in approximately 4 years worth of data. And this was actually a kind of a part 2 of their study because they managed to find 16 TNOs back in 2015, so this was really a continuation of their previous discoveries. And although we're not entirely certain about, for example, sizes or composition of these objects just yet, their existence in that part of the night skies is almost certain because the study was really comprehensive and actually took about 6 years to complete. And a lot of these objects will also help us point out where exactly the mysterious Planet 9 is hiding, but most importantly, we can actually now use the technique that they used to try to apply this to a much wider area of search and then try to discover where this Planet 9 is actually hiding. In other words, this particular study may have found a really good technique to finally discover where this object is, or if it even exists at all. But unfortunately, the study only covered about 4% of the night skies, and Planet 9 was not in that 4%, so we do have to kind of keep looking around. But since in the next few months or possibly years we'll be able to actually identify the orbits of some of these objects really precisely, this will allow us eventually to pinpoint where exactly the Planet 9 might be hiding. And interestingly, to make sure that they actually got the results that were correct and not false in any way, they even tried to trick themselves by introducing false data into their analysis, just to actually see if the technique that they used was legit and if it was able to identify actual objects. And according to the scientists, all of the objects they've discovered were definitely there and were actual trans-Neptunian objects, very similar to all of the other ones we've discovered so far. Although, like I said, it's going to be very difficult to determine their composition until, I guess, near future. And interestingly, about 30 of them were actually really far away, like over 90 astronomical units, or 3 times the distance of Neptune to the Sun. So a lot of these discoveries were in extreme locations of the solar system, and some of them could even be some of the farthest objects we've ever discovered, although this still needs to be verified. And despite the huge number of these objects we've already discovered, these scientists currently believe that we've only found about 10% of them, although it's actually possibly even higher than this. And so it will take years and possibly decades to finally identify most of these objects on the outskirts of the solar system. But luckily for us, the newly constructed and soon to be operational Vera Rubin telescope is going to be able to identify so many more with a lot more precision. And using a very similar technique to what they used here, these same scientists are planning to do this with the new telescope as well. And so it's quite possible that in the next 10 years or so, the number of these objects is going to be absolutely huge. But most importantly, the more of them we find, the more likely we're going to identify the location where Planet 9 is hiding, or finally solve the mystery of what's going on the outskirts of the solar system. Currently, this particular location, this part of the solar system, is still a bit of a mystery to us. And this is actually what we want to visit even more, because this is essentially what the entire solar system was made from a long time ago. Because some of these pieces have been completely untouched by anything in the solar system. Some of them have not even collided with anything for the past few billion years. So trying to get a sample from here one day would be pretty amazing. Hello wonderful person, this is Anton, and in this video we're going to be talking about the discovery of the oldest material in the solar system right here on our planet Earth, but inside of an asteroid that collided with our planet a few decades ago. So our story starts right here in Australia in 1969. The scientists observe a fall of an asteroid near a region known as Murchison in Victoria, Australia. So we're going to actually see how this collides here in the simulation, but this is really not the important part. The important part is that we were able to then recover this rock. Okay, that actually destroyed Australia by accident. Oops, was not supposed to happen. I think I might have created a rock that was a little bit too large. The Murchison meteorite looks kind of like this. This is what we were able to recover, and it's about 100 kilograms or about 200 pounds in weight. And it's been extensively studied over the years. We actually found out some really interesting things about the solar system from studying this meteorite. And things like, for example, organic materials, things like various amino acids and organic compounds that were discovered inside the grains in this meteorite allowed us to start understanding the evolution of the solar system and how all of the organic compounds probably arrived to our planet from the collisions of various asteroids and various meteorites with our planet. In other words, this rock taught us a lot about the evolution of the solar system and the evolution of our planet. But now it also taught us that it possesses a very ancient material and potentially presents a proof for a really important theory of star formation. So first of all, you can learn about all of this by reading the paper in the description below. This is from a study that was very recently published. But the idea here is that by looking at the tiny granules inside the meteorites, the scientists identified that these granules were formed way before our solar system, approximately 7 billion years ago, roughly around 3 billion years before the solar system even started forming. In other words, it came from the original gas cloud that created our solar system and probably a lot of other stars in the region. But also, these granules represent the so-called real stardust, the actual solar dust that created all of us billions of years later. These are literally solid samples of an actual star that then turned into various stars around the galaxy, and we normally refer to these as pre-solar grain minerals. The tiny bits of matter that eventually combined into objects like stars, and of course things like planets. But because back in college I did quite a lot of research on various asteroids and I remember how painful and difficult it was, I also wanted to find out how exactly did the scientists accomplish this. So I remember that when you actually try to study things inside asteroids, like this one here is one of the more famous ones, the Allen Hills 84001 is the asteroid that was discovered in Antarctica in the place known as Allen Hills, and it became really famous almost overnight because of the discovery of this unusual shape here. It resembled life, and because of this, scientists actually started speculating that maybe this was a sign of life from outer space. But then it turned out to be a somewhat natural phenomenon that was later reproduced in another paper. But in order to get these grains, the technique is really old school. You have to take the original rock and then use the mortar and pestle to grind it into tiny little pieces, which you then turn into a paste. This somewhat stinky rocky paste is then dissolved in acid, and this helps isolate these grains, which can then be studied and dated. But unlike typical carbon dating that we often use for organic matter, to date these rocks, a lot of other techniques have to be used. And for this study, the scientists used the idea that the cosmic rays that strike everything around the universe pretty much every single second will eventually turn certain materials into something else. And in this case, they looked at the amount of neon-21 that was produced over time. And the principle here is pretty simple. The longer something is exposed to cosmic rays, the more material we're going to discover. And by studying the amount of neon-21 inside of these granules, they discovered that some of them were anywhere from 3 to even 3.9 billion years older than the origin of our solar system. In other words, close to 7.5 billion years old. But this was only some of the grains. A lot of the grains, actually most of them, were still much younger. Some of them appear to be even younger than 4 billion years old. So in other words, this meteorite possessed a mixture of material from various ages. It's as if it accumulated all of this over the period of about 5 to possibly 6 billion years. And these probably came from our own solar system, but some of the material came from other star systems and basically the dust that created other stars, including our sun. And this is where it gets really interesting, because a lot of these materials seem to indicate that something major occurred about 4.6 to maybe 4.9 billion years ago, and also another major event occurred about 7 billion years ago as well. In other words, what the actual granules suggest to us is that a really major starburst activity occurred around this time. In other words, various stars started to suddenly being formed at the same time from the same cloud, and actually possibly several different clouds, all of which resulted in the formation of various stars, including of course our Sun. And it actually reinforces the theory we've had before that 7 billion years ago there was a major starburst formation that formed a really large amount of stars in our solar system. This has been speculated for a very long time, but the materials from this meteorite now present us with an actual physical proof that it very likely did happen. So here, this is where it gets even more interesting, because we now have a much better understanding of how galaxies actually evolve as well. In other words, here's what a typical starburst galaxy might look like if you were to look at it. This is actually very likely what the Milky Way looked like 7 billion years ago as well. Another real-life example is this right here. This is the antenna galaxies, and you'll notice that there are a lot of really large parts that are really bright. These are starburst activities. This is where many different stars, thousands, if possibly even millions of stars are being formed at the same time, and all of them from a relatively similar material. And we believe that this is exactly how galaxies actually grow, and how our Milky Way grew as well. Galaxies don't just evolve by creating stars constantly. The vast majority of stars in every galaxy are very likely created suddenly through these bursts, and then they kind of stay around for a little bit until the new gas cloud comes in and starts bursting again, creating even more stars. So all of these bursts of growth are very difficult for us to actually prove until we start finding samples like this that show us that something major did occur around this time. And another really unusual discovery from the study is that for some reason these grains tend to actually stick together very tightly. So these pre-solar grains actually come in chunks. They don't just come in tiny little pieces. And because we've discovered that they do tend to actually kind of accumulate into larger pieces, it means that we're going to be able to discover a lot more of these pre-solar grains in the near future by studying other asteroids as well. And by doing all of this, we'll eventually be able to kind of learn to understand how our galaxy evolved, what stars were created, what other stars were formed in the same region as the Sun. Most importantly, discover these so-called solar analogs, stars that are similar to our Sun, and possibly even discover the star systems that were created around the same time that might possess planets similar to Earth. And this is of course one of the major goals of modern science, trying to discover something else out there in space that might serve as a new home for us, or a place where we can discover alien life. Hello wonderful person, this is Anton, and in this video we're going to be once again talking about the second interstellar comet known as Borisov, and also a few other details about the new comet that's going to be possibly visible in about a month or so. This comet is known as Atlas. But today I wanted to talk about some of the updates, and also a little bit of history in regards to comets in general. Now first of all, this simulation right here shows you the difference between two interstellar comets we've discovered in the last few years. This is the Oumuamua and the Borisov comets, and as you can see, the second comet was actually moving a lot faster than Oumuamua, which is why we were so interested in it, because essentially this was a telltale sign that it came from the outside of the solar system and was probably one of the more unique objects that we actually got to investigate in a lot of detail in the last few months. Now in December of 2019, roughly around Christmas time, this is when the comet was at its closest to our planet, and this is why a lot of astronomers were actually referring to Borisov as the so-called Christmas comet. It provided quite a lot of various opportunities for scientists to study it in a lot of detail, and we actually had some of the most detailed studies about comets coming from this visitor right here. Now this is the Borisov comet as it was imaged by Hubble telescope, and right next to it you can see a tiny galaxy, just for comparison. And most of the studies focused on the composition and also on the amount of material that was being released by the comet. And so one of the more recent studies kind of summarizes everything we know about this so far, and it really is not as exciting as a lot of us were hoping this would be. In other words, this comet seems to be similar to a lot of other comets we've observed, both in terms of composition, structure, and even in some sense, size. The recent studies determined that it's actually a relatively small object. It's approximately 400 or so meters in radius, or basically about 800 meters across, which is, I guess, somewhere around 2,500 feet. But that's the maximum size possible. The telltale sign that this was not a big object was actually from one of the recent observations. The scientists made an assumption that there was about 10% chance that this comet is going to fall apart and basically get shred apart by the relatively close approach to the Sun. In other words, it was probably going to separate into tiny pieces and possibly become more than one chunk. And it just so happens that from the previous observations of other comets, we know that smaller comets have a lot less likely chance to fall apart because they just don't have enough gravitational force to keep them together. And here's what the most recent images of the comets look like. Here in this observation, it's quite obvious that it slowly starts falling apart and forms separate pieces that start flying away at a speed of about 1 foot per second or about 30 centimeters per second. As a matter of fact, the distance between these two pieces is about 180 kilometers. So this tells us that this comet is no longer a single piece, it's basically at least two pieces, but possibly even more than that. And the most recent observation discovered that it's kind of now even much smaller, and all of the other pieces seem to have disappeared completely. So this is actually the observation from just yesterday, from when I'm making this video, and here it's quite obvious that there's really just one piece again, even though there were several pieces in here previously. All of which allowed the scientists to very thoroughly analyze the composition of the comet, the amount of the actual material that's being ejected, and also even calculate the speed of the ejection, all of which we now know with a lot of detail. So for example, we now know that approximately 0.5% of the material was released really early on, and the comet was about 14 times the size of planet Earth if you were to measure just the size of the tail. The comet was losing approximately 62 kilograms per second, which is actually quite a lot of material lost, and the material itself was being released at speeds of approximately 4 to 7 meters per second, or approximately 20 feet per second. So this is essentially what gives a lot of comets a bit of a propulsion and changes their trajectory as they move across the solar system, which also allows us to then estimate how much of the mass was lost in total. We've also been able to analyze the composition of this tail, and for the most part it's either carbon-based or amine-based. Basically has a lot of the same components that normally form things like amino acids, and also a lot of other components that normally form organic molecules. And of course a lot of water as well. In other words, it sort of contains a lot of similar materials to what other comets in the solar system contain. The material, for the most part, that's responsible for bringing all of this organic stuff and all of the water to planet Earth and then helping the life start as well. Which of course implies even more evidence for other star systems having really similar conditions to our own solar system and possibly even having planets similar to Earth. But since we have no idea where this comet came from, we're not going to be able to answer the question of what kind of a solar system or a star system was able to create something like Comet Borisov. And so far, all of the recent images did show us that essentially this comet is being disintegrated really fast. It's probably already lost a huge chunk of its original mass and most likely became just the dust that you see right here that's going to be circulating across our solar system for the years to come. But it's also going to at some point leave the solar system because most of it is moving really fast. And even though we originally thought that maybe we could plan a mission to go here and to try to investigate this in a little bit more detail, because it's moving so fast, the earliest we could ever reach this comet would be 2045. And by then, it's probable that this comet is going to be really tiny, super small compared to what it was originally. So unfortunately, these are probably some of the last studies we're going to be hearing about this beautiful comet. Because now we have a new contender for the Comet of the Year, the comet known as Atlas. Discovered right after Christmas of 2019, this is now going to be the most studied object for the next few months or so, mostly because we expect it to be very bright and possibly even bright enough to be seen with a naked eye by the time of its closest approach to the Sun around late April or May. So if we're lucky enough, this could be that one comet we've all been waiting for, because it's been quite a long time before a comet was actually visible to us. The first time I've ever seen a comet was actually back in 1997. This was the comet known as Halley-Bopp, and it's not going to be back for quite a while. But the newly discovered comet known as Atlas is not an interstellar object, and is more of a long-term comet that actually approaches Earth every 6,000 years or so. So the last time we've actually seen this comet was around 4000 BC. Which actually kind of brings me to the other topic I wanted to briefly discuss, the word disaster, which is probably kind of related to what's happening around the world right now. The original idea for comets has actually always been the messengers of the god. This was true of pretty much most of the cultures around the world, including various Chinese cultures that have documented comets for generations, which actually is one of the reasons why today we know what comets are. because the astronomers of 18th and 19th century using the ancient Chinese documents were actually able to then start understanding them a little bit more. They realized that these objects do seem to appear periodically, and it was something that was natural and not something that was related to any kind of religion. But what's really interesting though is that both in the Chinese cultures and in ancient European cultures, the comets, depending on their shape and color, represented different things. Like for example, from what I remember reading, if it was a sword-shaped comet, or basically a tail that was a little bit curved, it would indicate some sort of a major warlike event. And one of the most famous comets, simulated right here in Space Engine, is the famous Halley's Comet. It comes around every 75 years or so, and has unfortunately been blamed for many different disasters around the planet. Now here's the thing though, the word disaster itself means bad star. And so until recent times, comets were actually disasters. They were bad stars. They were representations of something bad happening. Which is probably why in May, you're going to be hearing a lot of astrology reports on how this is basically the omen of the current pandemic that's going on around the world. But going back to the original images I showed you from China and from ancient Europe, these ancient images allowed us to understand that this is just something that happens regularly and can happen at any time. Pandemics are totally not related to any of this. And even though the earthquake in Switzerland in 1300s and also the outbreak of plague in London in 1600s, and even the assassination of Julius Caesar were all blamed on the famous Halley's Comet, this was of course before we understood what's really happening here. Thanks to the meticulous record keeping of the Chinese astronomers and various observations from early European astronomers, today we know that this is not what's happening, and we can easily predict comets even before they become visible and then track them for a very long time afterwards. And so, even though naturally people are kind of predisposed to blame various negative events on something unpredictable, something that we have no control over, something even astronomical, that's not really what's happening. And hopefully one day we'll stop relying on the ideas from astrology and from misunderstanding these space events, and slowly move on to the next chapter of human understanding, of being able to identify and also understand, predict and prevent various actual disasters from happening around our planet. But going back to the original topic of Comet Borisov, looks like its saga is finally over and we can now say goodbye to this beautiful object. We're probably never really going to visit this object, but it's very likely we're going to discover another interstellar object sometime in the next few years. Since we were able to discover these two so quickly, I'm sure another one will come our way pretty soon as well. But while we're waiting for those objects to show up, hopefully in May we're going to be able to see this beautiful Atlas comet and admire its beauty as well. This is something that doesn't happen very often and something that a lot of people will be seeing for the first time ever. So I'm actually pretty excited because I'm going to try to find the darkest spot I can actually find somewhere in the country, go there and take a lot of pictures of this beautiful object. Although hopefully by then the quarantine thing will be over, and if not, well, I guess I'm gonna have to wait until another comet shows up. And anyway, on that note, that's all I wanted to mention in this video. Check out the paper about Comet Borisov in the description below, and come back tomorrow to learn something you may have not known before. Also, consider supporting this channel on Patreon, it does help me quite a lot. Alternatively, you can also support this channel by buying the beautiful Wonderful Person t-shirt that you can find in the description below. I'll see you tomorrow, space out, and as always, bye bye.